Well, how did you do at this question? You really just needed to look back at the previous lectures and see that the interpretation of these quantities is that the mean is the best estimate, the standard deviation is our estimate of the uncertainty in each individual measurement, and the standard deviation of the mean is the uncertainty in the best estimate. And so the correct answer is A. The uncertainty in the best estimate is 30 parts per million.
So we're now ready to write down our final measurement of the door. We're going to write the mean plus or minus an uncertainty, which is just the standard deviation of the mean. And that SDOM has only one sig fig, despite all the work it took to take it. If you did it all again, if you do a new data set and get an SDOM out of it, you'll find they will usually only agree in the first sig fig. And then the sig fig for the mean is going to come from our sig fig rule for addition. Let me show you how that works. So we now have our mean of our height of the door, our standard deviation of h, and our standard deviation of h bar, the SDOM. And we're going to round that SDOM up to 0.0004. And then we see that since its only sig fig is in the fourth digit after the decimal place, that tells us that that is the last significant figure in our mean. And so our final answer is going to look like this.
By the way, I just said that the standard deviation of the mean always will have one sig fig. But if you think back to the very beginning of this part of the video lecture, the quoted value for the rate of precession of Mercury's orbit was given with an uncertainty that has two sig figs. Okay, the actual process for determining how many sig figs an uncertainty has is very, very complicated, and it's well beyond what we can do in this course. But with the types of data sets you'll have, which are rather small data sets, in fact, it would never have more than one sig fig. You need enormous data sets, like the data sets on Mercury's orbit, to be able to get even two sig figs in an uncertainty.
Remember that the whole point of this exercise was to be able to compare two numbers. So here's our final measurement, and remember we had this grand unified theory of doors that predicted this height for the door. Do these agree? Well, at first sight it might look like they don't, because that predicted h is outside the range that seems to be indicated by our measurement. Except remember that that uncertainty there is a typical variation. And by typical, we actually mean only about 2 times in 3. About 19 times in 20, we're going to see an answer within about 2 standard deviations of the mean of that, or 0.0008. And so we actually would accept this as agreement because it's within 2 SDOMs. That is our general rule. If two numbers are within 2 SDOMs of each other, then we say they agree within uncertainty.